Hey, you haven't done your current event lately?
Yeah, we got one today though. Good evening.
I heard of another one.
So we have a current event today, current event number 5, taken from the San Jose Mercury News yesterday. Infections taking deadly toll. And it's got the subheading, gastrointestinal diseases, particular threat to the elderly. Gastrointestinal infections are killing more and more people in the United States and have become a particular threat to the elderly, according to a new data released last week. Deaths from infections more than doubled from 1999 to 2007, from 7,000 a year to more than 17,000 a year, says the Centers for Disease Control and Prevention. Those who died, 83% of them were over 65. 2/3 of the deaths were caused by the bacterium Clostridium difficile. Which people often contract in hospitals and nursing homes, particularly when they have been taking antibiotics. The bacteria have grown increasingly virulent and resistant to treatment in recent years. But researchers were surprised to discover that the second leading cause of death from this type of illness was the norovirus. It causes a highly contagious infection, sometimes called winter vomiting illness, that can spread rapidly on cruise ships and in prisons, dormitories, and hospitals. I think there is perhaps misperception that norovirus causes a mild illness, said Aaron Hall, an epidemiologist at the Disease Center. But this suggests a major problem that requires some attention. Both diseases are spread by the fecal-oral route, meaning that people swallow germs found in feces, often spread by people who did not wash their hands after using the toilet. The problem with C. difficile are not new. Health officials first began warning in 2004 that a more virulent and drug-resistant strain had emerged. It produces high amounts of two potent toxins that can wreak havoc in cells lining the intestine. But few people realize what gains the bacteria have made. Among hospital patients, cases rose from 139,000 in 2000 to 336,000 in 2009. So almost 3 times as much in 5 years, or 10 years actually. In the article it mentioned that one of the problems is that you become susceptible to C. difficile. You become susceptible to C. difficile when you've been on antibiotics. The thing about this, and we're going to talk about some of this today and the next couple of sessions, is that our normal microbiota, the microbes that we have living in our intestines, they keep a lot of pathogens at bay. Their simple presence keeps those pathogens from attaching, establishing a foothold, if you will, multiplying and growing. And the thing with antibiotics, especially broad spectrum antibiotics, is that they target all kinds of bacteria, not just bad bacteria. So they target your own microbiota as well. And so you can depress your own intestinal microbiota, and that allows the Clostridium difficile to establish itself, and is why you can develop this kind of infection while you're on antibiotics.
So it's not necessarily fecal-oral route that was mentioned in the article?
That you can get this?
I mean, you could, but because when you're in the hospital, you're on antibiotics. Most of people get C. diff, related to the antibiotic use, and so I wasn't sure, hospital workers wash their hands very frequently, so I didn't understand that. So you could, but it's not necessarily.
No, it is how you come in contact with it. The point is that when your intestinal population is normal, the minimal amount that you would come in contact necessarily is going to be suppressed. But when your population is being suppressed, your microbiome, then what you're being exposed to can become established. Okay? So it's still a fecal-oral transfer. And in some cases, and I hear what you're saying, this is also, for a lot of people, part of their normal microbiota as well. It is part of their intestinal microbiota that's kept that way. So, but it is also spread through fecal-oral. And so, and same with norovirus. Both of them are spread that pathway.
I was going to say, it's the other thing that doesn't always happen in the hospital. The doctor can prescribe antibiotics. You can go home and take those antibiotics and then get exposed to the fecal-oral route. And obviously be immune compromised at that point.
Good point, yeah. He does raise a good point there. Thank you, Mark.
So how does like the norovirus, for instance, I was reading in the paper last week, school in Marina.
Yeah, 114 students.
They end up with like, you know, they had how many, 75, 80 people within the course of an hour with the norovirus? How does it spread if it's fecal that quickly in such a population? I mean, are all those kids running around licking each other's fingers or something?
You would be surprised at how quickly something like that can spread. You don't. All you got to do is be touching each other, touching doorknobs, touching the same doorknob. You know, they're all running in and out of the same bathroom, in the same environment. Yes, it can happen that quickly. Sure. And especially one that is virulent like that comes on, that has a quick onset. Absolutely.
Yeah, definitely.
I experienced something like that last semester as well. Felt fine in the morning. I was outside playing with my dog, and then suddenly I kind of got nausea and dizzy. Went upstairs to take a shower, and I couldn't even get in the shower. I just started vomiting and throwing up, and I was sick for like 30 minutes, where I just couldn't move, and went to bed. 2 hours later, woke up, and I was better, you know, and I was up doing what I normally do. So yeah, they can come on that quick. What caused it? Yeah, I'm not sure. I could have been exposed to something. Maybe it was an intoxication. But back to the norovirus. Yeah, if you're in closed quarters, like a lot of times you are in a school, it's very quickly for the entire area to be contaminated now. You know, one child that's sick touches a doorknob, and then touches several drawers, and then he's, you know, touching other kids. You know, and then pretty soon everybody in there has been exposed to it. But yeah, you brought up a good point. Last week in Marina, I thought it was 114 kids.
There was quite a few numbers, including a couple adults.
It happened in one day, didn't it?
Yeah, it was right after.
They weren't all sick.
They weren't all sick?
Only the first, only about the first 20 that went home were actually,
But
the rest.
took precaution with the others. Any other comments? Questions? Okay, so the other thing I mentioned is that this microbe is becoming more resistant to the drugs that we are using on it. And that's where selection pressures, mutations, things like that can lead to new gene products that then give the microbe the ability to, you know, thwart or avoid the antibiotics that we might be using. If the antibiotic is targeting a certain protein or a certain molecule on the cell surface, and you change that molecule so that it's different now, then that antibiotic doesn't recognize it, doesn't target it. So for the next several weeks, we're going to be talking about immunity and how our body fights off infection, how microbes counter those defense mechanisms. We'll look at some hypersensitivities, and then we'll finish the semester off looking at specific systems and some specific diseases and microbes, the diseases that they cause. Today we're going to start with talking about the innate immunity. This is chapter 15. If you stop and think about it, we have a lot of bacteria on us and a lot of bacteria in us. You know, we actually have more bacterial cells on us and in us, if you will, than we have normal body cells, regular somatic cells. But here's the thing. None of those cells are really inside our body. None of them are in our tissues at all. Our tissues in our body proper is sterile. If you were to take me and cut me in half and look at me, from a top view, I'm really a donut. Okay? I have a digestive tract that runs through me, and then I have my organs and tissues and bones and muscles. Then I have the outside environment. This is outside, both of these are outside the body proper. We have lots of bacteria in here, and lots of bacteria out here on the surface, but we don't have any bacteria in here. If we do, we have an infection. An infection is when bacteria have invaded tissues, and now they're causing some kind of condition. We'll talk more about that here shortly. So, innate immunity refers to that immunity that is non-specific. They like to say it's the immunity that you were born with, but I prefer to refer to it as non-specific. As we'll see with adaptive immunity, which is the second type that we'll talk about in chapter 16, adaptive immunity is very specific, targets specific molecules or specific microbes, but our innate immunity, non-specific. It's going to protect us from a broad range of microbes that we would be exposed to. When we think of our non-specific defenses, we can identify them as first-line defenses, and those are going to be the defenses that try to prevent the bacteria from actually getting into the cells. So our first-line defenses will include barriers, physical barriers. So our skin and our mucous membranes, they serve as physical barriers. Non-specific, because they're going to prevent all bacteria from entering the body. When we think about the skin, the outer layer, the epidermis, this is a layer of many flattened cells stacked up onto each other, tightly packed, impenetrable to water, and for the most part, bacteria as well. The only way that bacteria can get past the skin is if there's been damage to the skin, if you've cut it or you've abrased it, done something like that. Otherwise, bacteria can't get across the skin. It serves as a great barrier to prevent infection. In addition to that, if you think about the environment of the skin, it's going to be a very arid environment, it's going to be dry, it's going to be salty, isn't it? So that's going to limit the types of microbes that might be able to grow there. And we slough off skin all the time. And with the sloughing, you're losing bacteria. So it's a way of controlling your microbial population. Sloughing off the skin also sloughs off bacteria. Mucous membranes are the second physical barrier that we can list here. And now we're talking about the membranes that are lining the digestive tract, if you will, and the respiratory tract, the interior part of the lining there. And with the mucous membranes, a couple of things that we need to keep in mind. The cells themselves secrete the mucus. And this mucus serves then to bathe the surface there and captures bacteria, dust particles, and other things that you might be inhaling. In addition to that, many of the cells are ciliated, and so the cilia serves to sweep the mucus up out of the lungs and allows you to expectorate or swallow the bacteria that have been captured in this mucus. Antimicrobial substances that we might have in some of the fluids that we secrete. Serve as a first-line defense. So, just on the surface of our skin, the sweat that we are secreting serves as